All right, welcome everyone. Thank you so much for coming today. I am really excited to be telling you about how to perform Pandas-style queries on computer vision data using FiftyOne. There's also a tutorial, a Medium blog post, and a cheat sheet on this topic. So you should also check those out if you get a chance. Before we get started, just a little bit about me. I am a machine learning engineer and developer evangelist at FiftyOne. I joined the team back in October, and we're actually still hiring. So if you're interested, you should apply, definitely. It's a great place to work. Anyway, I am new to FiftyOne, and I'm new to computer vision stuff as well. So I've been learning a lot of this very recently, and the Pandas 51 analogy was very helpful for me, and I really hope it's helpful for you as well. A couple of housekeeping announcements. If you have a question, I know Jimmy posted something in the chat recently. If you have a question, please use the Q&A widget instead of putting it in the chat. We get another thing in the chat just now. And if you put it in the Q&A widget, that'll help us to organize everything and to make the Q&A available in a summary format after this so that you can get a copy of that. Also, the webinar is being recorded, so a playback will be available on YouTube. One other announcement is that we are also going to be donating to charity on behalf of the participants today. So FiftyOne will be donating $100 on behalf of the attendees, and your vote counts. So choose one of these wonderful charities, and we will be making it a donation based on the votes that we receive. Awesome. So if you're here, that means that you're probably familiar with the Python open source library for dealing with tabular data that is Pandas. That, or you're a really big fan of big, fuzzy, bamboo-eating bears. And if that's the case, we've got it covered as well. But Pandas, the library, makes it really easy to manipulate, access, and deal with just in general tabular data. Think rows and columns. And when I say query here, and query is the main topic of today's talk, querying just means very generally in the sense accessing, manipulating, getting subsets of the data and performing operations on those subsets. Now, Pandas is really flexible. It's really good and fast at the things that it does, but not all data is well represented, well stored, well handled in a tabular format. And we're going to be talking about one particular class of data today, and it's a pertinent class for those of us who are here, that is computer vision data, which is often not easy to put in a tabular form, and often we don't want to even put it in a tabular form. So today we're going to be talking about how to perform Pandas-style queries on that unstructured, more general form computer vision data. So computer vision data, whether you're dealing with images, videos, satellite imagery, LiDAR, or other 3D data, it can be quite unstructured. And I'm not talking about the pixels here, I'm talking about all the metadata that goes along with the computer vision data. So think like detections, key points, segmentation masks, relationships between pieces in an image. All of these things can be a little bit more flexible than would typically fit in a tabular format. So an example of this is detections. When you have a set of images, you don't necessarily think that every single image is going to have the exact same number of detections. So you don't want to have a set number of rows to actually structure those detections. It could be that one image has 1 or even 0 detections, and another one has 10, 20, or 30 or 40 detections. So we want a flexible way to handle those types of possibilities. Another thing is tagging. Some images might have tags, and tags can come in various forms. Other images might not have tags. Enter FiftyOne. So if you're here today, you probably have a sense for what FiftyOne is. For those of you who don't, FiftyOne is an open source data-centric machine learning solution. It allows you to curate, visualize, and analyze datasets, helps you to build better datasets and models, plugs into a bunch of your machine learning workflows. I assume most of you are familiar with it, but we will be getting into it soon, and I'll be showing you how to get it set up in a moment. FiftyOne is what's going to allow us to perform these types of Pandas-style queries on our computer vision data. And I've also taken the liberty of generating a data set of pandas so that we can perform Pandas-Style queries on pandas. This data set is something that you guys can also generate by yourselves. I generated it through images.cv, and the link to generate this exact data set will be shared in the Colab notebook, which accompanies this. So in a moment, we're going to be switching over to a Jupyter notebook, and we'll be doing a live demo walkthrough. There will also be the Colab notebook, as I mentioned, and that should be shared. The link to that should be shared in the chat soon. That means that you can follow along if you want. You can run the code yourself. You can play around with it, modify stuff if you'd like. Don't feel the need to. We will be going through this on the go, live, right here. A quick word about setup, though, is we will be starting from the point of having a data set ready to go. We will be investigating that data set. So in order to get things set up, you will need to, and these details are in the setup section of the Colab notebook, you will need to download FiftyOne, install FiftyOne, download the data set from images.cv, import FiftyOne, load the data into FiftyOne, and this is just one example of how the types of data sets that you can load into FiftyOne. There's a whole variety of ways you can load data into FiftyOne. And then I've also generated predictions on this data set so that we can play around with them. Generated predictions for some classifications and for some detections. I've also already computed the metadata, uniqueness, and mistakeness. So this sounds like a lot. In reality, a lot of these things are single lines of code, and you can see that in the notebook. But we're going to be starting from the point of having this data set ready. And the quick agenda for today is we'll be talking about the basics. We'll be going through summary statistics, how to do filtering and matching, how to get specific subsets of your data set that are of interest to you. And then throughout this entire time, we'll be talking about how to improve your data set quality using the insights that you're able to glean from these processes. We just check there's no questions. Good. Okay. Awesome. All right. Let's switch over to the live demo. Okay. We just got a question. Okay. Now we're good. All right. All right. So as I mentioned, we're going to be starting from the point of having a data set. Now, the first thing we do when we start with the data set is we want to understand what's going on in the data set. That means we want to get a high level picture of what is the data set, what does it contain, what do the different samples look like. And this would be the case whether we're dealing with a computer vision data set or another data set. And throughout this entire flow, I'm going to be talking about how to think about the types of things that we would be doing on tabular data in Pandas and the analogies in FiftyOne. So how to basically understand our and get a feel for it using Pandas-like functionality in FiftyOne. So to start out with, we've got this data set, and here, the first thing we can do, we can look at the type of the data set, and this is a data set in FiftyOne. We got something in the chat. Okay, Jimmy or Michelle or Brian, one of you guys post the link in the chat. Thank you. Okay, so we can look at the type of the data set. We can also do things like print out the data set. And here we can see, I've named this data set Pandas Workshop. I've got 200 samples here. The media type is images, and we've got a bunch of other data that we'll get into soon. But this command right here would be equivalent to if we have a data frame in Pandas, df, doing df.info, something like that. Something else in the chat. Okay. Doesn't look like the link was shared. Let me share it. Okay. Hopefully that helps. Okay, so we can print out the data set equivalent to getting the info of a data frame in Pandas. We can do things like look at the length of the data set. So we can do dataset.count, which is going to give us the number of samples in the data set. That would be equivalent to doing something like length of the data frame in Pandas. Other things that we can do are we can actually look at individual samples. So we can, for instance, in Pandas, you might be familiar with like df.head, that allows us to something else in the chat. Okay, all right. I'm gonna assume that Jimmy and Michelle and Brian are handling the chat for the moment. So in Pandas, you can look at the head of the data set and you can actually put in parameters. You can put in a number that will give you the first n rows of the data set. We can do something similar in FiftyOne. So we can get the first few samples in the data set. And in FiftyOne, samples are the analog of rows in a Pandas data frame. Samples are a little bit more flexible. That's what we call the individual media files and all of the accompanying metadata. So here we can see this returned a bunch of samples. If we want to, we could also just look at a single sample. So the first function gives us just the first sample in the entire data set. And here we can see each of them comes with an ID, media type, file path, where the actual media file is located, because all of this, all the data that's stored in this data set, it pertains to the metadata and all the stuff that accompanies the media file. But the data set here does not actually represent, it doesn't actually contain all the information for the image or the media file itself. And that will be stored separately. It also has metadata, including the width, the height of the image, things like that. And then we have this ground truth field. And field, as we're going to get into shortly, we got another question, something in the chat. Okay, this will be on the Voxel 51 YouTube channel, and Jimmy or Michelle can share the link to that. So we have a ground truth field, which is a classification object. And here that just means that there are a bunch of different options for what the image could have been classified as a whole. Here we see that the image was classified in the ground truth as a giant panda. And that's what we're going to be using as our source of ground truth, as our source of truth here. We also have a ResNet 50 field. And this is the generated prediction classifications. And for this particular sample, it was also classified as a giant panda. We have confidence associated with that. This is very confident that it's a giant panda. And then we have another field, faster RCNN, which is the model I used to generate the predicted detections. And we can see there's actually multiple detections here. And in general, this could be an arbitrary number of detections. And one thing you might be noticing throughout all of this is that the structure that we're using inside of the sample is actually very flexible. And we have these nested lists of these fields. So instead of just having columns in a data frame in Pandas, where the columns are fixed, you can have a much more flexible structure with these type of embedded fields, is what they're called in FiftyOne. And the syntax I'm going to show you very shortly in order to handle, to query, to perform these operations on your computer vision data allows you to take the simplicity of Pandas queries and apply that to these potentially nested, potentially much more flexible data structures that you encounter in computer vision workflows. And as a side note, there's also tail, which gets you the last couple of objects, the last couple of samples in your data set. And there's also last, which gets you the last one. Now, from there, other things we might want to do is look at what are all the fields we might have. And that would be equivalent to doing, getting all of the columns of a data frame. So how can we do that? How can we get a list of all the fields, the entire structure of all the fields in our data set? Well, we can do that by using the get field schema method. We can get the keys of that field schema. And so this gives us a list of all of the fields that we have in our data set. And here we can see we were looking through these, but these are all the fields that exist across all the samples in our data set. Okay, so we've been trying to get a sense for high level what's going on in the data set. And the things we've done so far, even though that includes some flexibility, it allows us to handle the unstructured nature of computer vision data. One thing that we haven't done is taken advantage of the fact that these are actually images. And if you want to get to understand an image-based or any computer vision data set, one very important thing is actually viewing those images or viewing those media files. And FiftyOne makes it very easy to do this as well. So this is a big piece of the picture. We can do that with the FiftyOne app by launching the app. So we can create a session and launch the app. and pass in a data set. And here we can see a bunch of images of pandas. What a coincidence. And here we can see on the bottom of each of these images, there's two labels. And one of these is the ground truth label. So what our image was labeled as to begin with when I downloaded it. And that is giant panda for a lot of these. And then we can also see the classification. So what the prediction model that I used classified the image as. Here, that was also for many of them giant panda. We can also go into the individual images and look at all the details here. And we can see a bunch of bounding boxes, for instance. So there's a bunch of detections on these. I'll get into more of this in a moment. But taking a step back, we can see a lot of bounding boxes here. There's a lot of detections in all these images, and that could be a problem. So that's something that we're going to want to investigate very shortly. Looking in the chat. Okay, great. Awesome. All right. So the next thing we might want to do is, now that we have a sense for high level what the different pieces are that we're dealing with, what are the types of values that the different fields have? So what are the things that you might expect to see in the fields? And FiftyOne provides a way to do this as well. So this should be equivalent to if you had a data frame, you could get a column. So if you had a column name that was like column A, you could use this syntax right here, or you could also use the dot syntax and get it like that. We could do something similar in FiftyOne. So let's say we want to get the ID. So if we want to get the ID of a sample, and here let's just say our sample is the first sample in our data frame. If we want to get the ID, we can do that, or we can use the other syntax that Pandas enables. Now, one cool thing is this also works for nested fields. So let's look at the sample again. And here, for instance, if we want to get the metadata, we can use the dot syntax to get the metadata, and then we can actually append another attribute to this to get a nested field, or we can do something like this. Either works. Sorry, not for that. Sorry, not that one. But there, if we want to get a sample of ground truth here, and then we want to get confidence. Brian, I might be missing a syntax here, but the point this should work. Anyway, we can also get the values in a particular field. So if we want to get all the values that exist for instance, the file paths, and is that Brian? Yes, thank you. Sample dot ground truth dot confidence. Cool. Awesome. Now, if we want to get the values, we can do dataset dot values. For instance, let's say we want to get all the file paths. Here we get a list of all the possible file paths in our data set. So this should be a list of 200 file paths. We can get a list of all of the values for uniqueness right here. We should be able to get a list of all the values for like ID or other things like this. And we can also do something like, let's say we have, we want to get the values of all of the labels. So we want to get the values of ResNet 50.label. Here, this is giving us all the labels that we had for our classifications. So this is for every image, we had one value that was returned. Now, we can see a lot of them gave giant panda. So something we might want to do is, okay, well, what are all of the possible values that we actually had as classifications? And in that case, we can use the distinct. And that would be equivalent to doing something like df.unique in pandas. We can do something similar for our detections. And to do this for our detections, we could do something like copy this. And instead of using our classification model, we can pass in the field corresponding to our detection model, and we can then use the detection subfield here, and this gives us a list of all the detections, the distinct detections. Now, if we wanted to get all detections, we could use the values, and here we see we have this nested list right here. So there is a list of detections for each of the samples. So if we were to get the length of this, there's 200 because there's one for each sample. But if we wanted just a flattened list here, we actually can do that very easily by just passing in unwind as a keyword. Okay. So one thing we can see here is if we're looking at all of these values, and we, for instance, let's say we want to look at the distinct values here, we scroll through, there doesn't seem to be anything that relates to pandas here. And that might be a problem for us. So we're trying to detect or classify pandas, and our classifications and our ground truth all have to do with pandas. And yet there's no mention of pandas in this list. So what's going on here? And we can just check this, like giant panda in this, false, or even just panda in this. Yeah, there's nothing relating to panda in this. So what can we do? Well, let's load up the FiftyOne app and investigate this. So session.show. So we can use the session.show command to actually pull up the FiftyOne app, and we can take a look at some of the images. And here we can see that there isn't anything relating to giant panda or panda in terms of these bounding boxes for detections. But if we go through a couple of them, we can kind of get a sense for, here there's a bear. Here there's a bear. On a bunch of these, it seems like there's a bear. We go through more of them. There's a bear here as well. So maybe it's using bear to classify as panda. And you know, that could be just as our detection model wasn't trained on pandas, it was trained on bears as one of the categories. And that indeed turns out to be the case here. The bear is the closest thing. And so we'll go through and we'll use that moving forward. Okay, so we're gonna move on here. The next thing you might wanna do when you're investigating your data set is to look at some aggregate statistics. So if you wanna get a summary of some of the statistics in your data set to better understand what are the ranges and what are the typical values that certain things might take on. And FiftyOne makes it easy to do this in a very similar way to pandas as well. So if you want to get, for instance, the bounds, the min and the max values possible for a particular field, you can do that, for instance, using the bounds method. And let's look at the bounds for our classification model. Sorry, our detection model. The confidence that it spit out. And this shows us that for our detections, there were some detections that were very, very confident. And this right here, the last value is the max and the first value is the min. So we could have like min max is equal to this. And here, even though this is very high, we have some very low confidence predictions. And we can do something similar for our classifications. So we can pass in the field in which our classifications are stored. And we can see that even our least confident classifications are still more confident than our least confident detections. We can also do things like get the mean. So instead of using the bounds keyword, we can use the mean. And here we see that our average confidence for our detections was fairly low, but our average confidence for our classifications was actually remarkably high. If we wanted to, we could also do things like get the standard deviation. And all the syntax mirrors pandas very closely. If we wanted to do more complicated things like get the median or other aggregations that we might want to implement ourselves, we can do that by basically just getting the values. And if we need to, passing in the unwind equals true method or a keyword. and then passing that to a defined function that we've defined. So we've gotten the mean, we've gotten the standard deviation, the bounds. What about something more flexible? So if we want to get the values that a certain quantity takes on at particular percentiles or particular quantiles, we can do that with the quantiles method. So if we use, for instance, let's say we want to get what happens at these particular values right here. So we want to see what happens at the 20th percentile, 50th, 70th, and 90th percentile. We can define those, and then we can see what happens there. Quantiles of uniqueness. Maybe uniqueness wasn't actually implemented the way I wanted it to be here. Let me just go through and fix that real quick. Yes. Okay. All right. So now when we compute this, yes. Okay. Now that works. Great. So we can get quantiles. And we can also do something really cool, which is we can compute aggregate statistics over properties of embedded fields, which is something that you wouldn't be able to do. It's not something that would make sense to do in Pandas, but it's something that could be very useful in the context of computer vision data. So as an example of that, let's say we want to count the number of detections on an image. So for an individual image, and we can just take this sample as the first sample in our data set, as we've been doing. If we look at that sample and we go to the detections field, and then we get the detections, here we can see that that sample had 8 detections. But we can actually do this type of operation across all the samples in our data set and aggregate that using the ViewField, which I've imported here as F. So you can see that above, but it's from FiftyOne, import ViewField as F. And this is something that we're going to be using a lot moving forward in the rest of this workshop in order to create custom expressions that allow us to filter and query our data set more flexibly. So here, what we can do is, let's say we want to get the mean number of detections, and we can use this F to have a symbolic expression. So we're passing in the detections subfield, and then we can get the length of this detection subfield for each sample. And when we do this, we can see that on average, our data set, every single sample has almost 14 detections, which is a ton. And a lot of those are very low confidence detections. So that's something we might want to work on. We might want to either go back to our model at the end of the day and raise the confidence threshold, or we might want to just basically threshold those out right now, which is something that we'll do when we actually do the filtering. We can also do something like bounds here, and we can see that the image that has the fewest detections has 2, and the image that has the most detections has 40. Okay, so now we've gotten a sense for what the high-level properties of our data set are, what the things that it contains. We have a sense for what the aggregate statistics are. Now let's get into some of the more interesting, more complex stuff. And to do these queries to get pieces or parts of our data set or subsets, we're going to use filtering and matching. And for instance, let's say we want to look at the most unique images in our data set. One way we can do that is we can create a new view using the match method. Applied to the uniqueness field. And let's say we want to get only images that have above a value of 0.8. And uniqueness is something that ranges from 0 to 1. So when we do that, we can actually view this as well by just resetting the view for our session. Unique view. And we can see there's only actually a few images that are this unique. And looking at the most unique images can be very helpful when you're trying to get a sense for your data as well. Now, let's say we didn't want to set a particular threshold, we wanted to just sort our images by uniqueness. If that's the case, then we can do something like using the sort by. So unique view is equal to sort by, and then we can pull in the same stuff that we had here. And then we can use reverse equals true to show us the most unique images first. And then we can go up, and here we see we have our full grid of all the samples just sorted by uniqueness with the most unique images first. Now, in pandas, we can sort as well. We can sort by particular properties. We can also filter, as we've done using the 0.8 threshold, doing something like, for instance, unique data frame is equal to like df of then the property by which we want to sort or filter, and then threshold. So this is the analog of that. Okay. Now, let's say we want to just view images that are very crowded. So let's say images that have more than 10 predicted detections in them. We can do that as well. So let's create a filter separately that we're going to then apply. We can use the ViewField and say, taking our detections subfield and looking where that is greater than or equal to 10. And then we can create a view that matches to images that satisfy this. Okay, and then we can view this as well. Crowded filter. Yeah. Okay, so this is all the images that are very crowded, that have at least 10 detections in them. Okay, let's do something different. Let's look at the images which have very high confidence detections. So we can do this with like high confidence filter is equal to f of confidence. So we are just imposing a threshold on the confidence that we're going to then pass into the detections field. And then we can create a view from this. And you'll see a pattern here of creating filters and then creating views using these filters. And in general, the match and filter methods are incredibly powerful in FiftyOne. So here we can then pass this into the detections. And filter by this. And then get all of the, we can get all the images that have with high confidence, at least one very high confidence detection in them. And then we can view this. This is this. Okay, and there's actually only a few high confidence detections here. And when we look at these, we can see a couple of problems emerging. And this is something that will allow us to potentially improve our data sets and improve our models moving forward. So there's only a few high confidence images, and we can see that some of these, 3 out of the 4 here, were actually classified as not a giant panda, but something else entirely. And when we look at the detections, let's do session.freeze. So this stays. What was the thing that was actually high confidence here? It was a person, not a panda. And again, we have a person and a person and a person. And this presents a question for us as machine learning engineers, as computer vision engineers. How do we want to handle this? Do we want to send these images in for like re-evaluation? Do we want to say, hey, these images where people are the dominant features and not pandas, we want to still be able to classify those or detect pandas in those with highest certainty. And we want to just have more images like this that we then fine tune the model on to be able to detect or classify as pandas? Or do we want to say, hey, this is an edge case, and actually maybe we don't want to include these images in our data set to begin with? That's a choice that we can make, and we can then send these images with our tags that we might add to them out to a labeling or annotation service. And FiftyOne has a bunch of those integrations with Labelbox, Label Studio, and CVAP. And the resources for those are all online. Okay. Another thing we might want to do is sort by how wrong our predictions are. So we can look for the most quote unquote wrong predictions, the predictions where our model was most confident, but predicted something that was different than the ground truth. And this is something we're going to do for our classifications right here. And we're going to use the mistakenness field of our data set. So here we can create a mistaken view. We're going to sort by this property. Mistakenness. And then we're also going to put the most mistaken images first. And then we're going to also view this. Okay, so when we view this, we can get a sense for why our model actually predicted the wrong thing here. Well, for one, we do this. This one has a bunch of sub-images. So it's easy to see why the model didn't say this was a panda on the whole, because it's a bunch of images of pandas, and the structure that it has is a little bit different. Some of the other images, so if we look at this one, it was classified as a prison, and it's a cage. There is a panda in there, but it's understandable why the model said, hey, this is a prison, because the cage is a very dominant feature. And we can see a couple of other things like that. Here, there's something which was classified as a panda, or sorry, it was classified as a mobile home by our model, but it was supposedly a giant panda in the ground truth. And that's something that actually looks like a mistake in the ground truth. So we want to send that back for annotation and reevaluation. Okay. One thing we might want to do as well, and this is the final thing we're going to do here, is we can compare our classifications and our detections. And the motivation behind this is when you have very large bounding boxes for your detections, when the bounding box takes up almost the entire canvas of the image, then the information that goes into that bounding box is into that detection model's classification is very similar to the information that goes into the classification of the entire image. So we would expect the results to align best in those cases. So let's start by generating a view that only includes large bounding boxes. So large, let's make a filter. So we can create an object, an expression that corresponds to the bounding boxes area. And here I'm just using the format of the bounding box, which is in the initial X position, initial Y position, and then the width and height. And those are in relative coordinates relative to the size of the image. If you want the absolute coordinates in terms of number of pixels, then those details are in the metadata. So here we're going to get the width, and then we're going to get the height. And this shows you one of the ways that you can make these more general expressions that then you can use to filter your data set. Then we're going to use this to create a view. We're going to filter out the labels in our detections that have a bounding box area that takes up more than 80%, let's say, of our canvas. And then we can, let's say we just want to view these. Box area. Okay, so we see a bunch of very large bounding boxes, and it looks like the rest of them were actually omitted in this view, which is what we want. So now let's look at all of the large bounding boxes images that contain at least one bare classification. So we can create a new view that starts from the large box view that we just generated and tries to find if there is a detection which is a bear. And here we can check if there's any that is a bear by using the contains method. And then we can, for instance, look at the number of images that satisfy this. So there's 17 images that have very large bounding boxes that are bears. And finally, we can say, okay, let's say the images that we're very sure are panda bears are things that our detection algorithm said has a large bounding box that is a bear, and our classification model says the whole image is a giant panda. And we can do that by creating a new view, definite panda view, we can call it, and large box bear view. So we're going to start from all the images that had large bounding boxes, which were classified as bears, and we can match for our classification being equal to the label that we're interested in. And then we can print out the count of these. Unmatched. Here, what do I want to do here? Am I missing one? Yeah, okay. So every one of the images that had a very large bounding box that was classified, that was detected to be a bear, was also classified on the whole as an image that was a giant panda. So in this case, these 17 images out of our 200 that we started with are the ones that we can probably with very high degree of confidence use as the starting point for whatever algorithm, for whatever procedure we want to use to then iterate on this and to improve our models. These are things that we could, for instance, use to pre-label a bunch of new data. So if we wanted to, for instance, embed all of our images into a lower dimensional embedding space and then visualize them and try to do some type of like classification or k-nearest neighbor type clustering or something like that, and take all of the images that are close to or are in the same cluster as these 17 images, we can pre-label those as being pandas. So we're going to stop there, but the important thing here is that FiftyOne allows you to extend the pandas type querying functionality that was available for tabular data to the much more flexible, unstructured things that you might expect and encounter in computer vision workflows. And in particular, all of these filtering and matching and querying operations that we've used today have helped us to better define ground truth, to find mistakes in the ground truth that we need to correct, to figure out what are some edge cases that we might want to decide how to handle, and to see that we need to increase the confidence threshold of our detection model. So these are just a few ways that just some very simple querying and visualization can allow you to better build models and data sets. So I'll stop there and we'll open it up for questions. I know we ran a little bit long, but opening up for questions now.